Welcome to the next video of inverse trigonometric function. We had already started solving example based on inverse trigonometric function. In this video also we are going to solve some more example based on inverse trigonometric functions. Mainly we are going to use properties of inverse trigonometric function. So example is prove that cos inverse 4 upon 5 plus cos inverse 12 upon 13 that is equal to cos inverse 33 upon 65. Now what we have to do, first we have to take this cos inverse 4 upon 5 as theta and cos inverse 12 upon 13 as 5. Okay. So let cos inverse 4 upon 5 is equal to theta and cos inverse 12 upon 13 is equal to 5. So from cos inverse 4 upon 5 equal to theta, we are taking this cos inverse on right hand side. So we get cos theta. Cos theta is equal to 4 upon 5. And since cos inverse 12 upon 13 is 5. And I am taking this cos inverse on right hand side. So what I am getting? Cos 5. Cos 5 is equal to 12 upon 13. Okay. So cos theta is equal to 4 upon 5. Cos 5 is equal to 12 upon 13. Now what I am going to do? I am going to draw a right angle triangle. So in right angle triangle, suppose this angle is theta. So cos theta is given as 4 upon 5. Cos means adjacent upon hypotenuse. So this side is 4, this side is 5. So this side will be root of 5 square means 25 minus 4 square 16. So root of 9 means that is equal to 3. Okay, I got this side. This is 4, this is 5 and this side is 3. Then cos theta is given. So now I have to find sin theta. So sin theta will be opposite upon hypotenuse. So sin theta is 3 upon 5. Okay. Cos theta is given and by using cos theta I found sin theta. Okay. Now similarly we have to do for this phi. So cos phi is 12 upon 13. So again I have to draw a right angle triangle. In right angle triangle this angle is phi. Okay. So cos phi is 12 upon 13 means this side is 12, this side is 13, right? So this side will be root of 13 square 169 minus 12 square 144. So that is equal to root of 25 means that is equal to 5. Okay. So I got this side by using Pythagoras theorem. Okay. Now this side is 5. So cos phi is 12 upon 13. So what I have to find? I have to find sin phi. Sin phi will be opposite upon hypotenuse. So phi upon 13. I got sin phi as phi upon 13. Okay. Clear? First step is I am considering this cos inverse 4 upon 5 as theta and cos inverse 12 upon 13 as 5. Then I will get cos theta as 4 upon 5 and sin phi as 12 upon 13 by the definition of inverse trigonometric function. Then I draw this right angle triangle and cos theta is given. So I find sin theta. Cos phi is given. So I found sin phi. Okay. After getting all this value, now next step is, see here what I have to prove. I have to prove that cos inverse 4 upon 5 plus cos inverse 12 upon 13. Right. This cos inverse 4 upon 5 is nothing but the theta. Right. I consider this part as first part as theta and cos inverse 12 upon 13 as 5. Right. First part is theta and second part is phi. So this is theta plus phi. Take this cos inverse on left hand side. So that will be a cos. So the term will be cos theta plus alpha. Clear? What I am taking? Cos theta plus alpha. Why? Because this theta is what? Cos inverse 4 upon 5. This 5 is what? Cos inverse 12 upon 13. Right? And on right hand side, what is given? Right hand side is cos inverse. Right? So when I take this cos inverse on left hand side, it will be cos only. So cos, first term is theta plus second term is phi. So cos theta plus phi. So I am taking cos theta plus phi. And this is nothing but cos A plus B form, right? So I have to apply cos A plus B formula, and that is equal to cos A cos B minus sin A sin B. So cos theta is 4 upon 5 into cos phi is 12 upon 13 minus sin theta is 3 upon 5 into sin phi is 5 upon 13. So after multiplication, what I am getting? 48 upon 65 minus 15 upon 65. So 48 minus 15 is 33 upon 65. And left hand side is cos theta plus phi. And now I take this cos on right hand side. So that will be a theta plus phi, that is equal to cos inverse 33 upon 65. Now theta is what? Theta is cos inverse 4 upon 5 plus phi is what? Cos inverse 12 upon 13, right? That is equal to cos inverse 33 upon 65. Okay, hence the proof. So very simple. First part is considered as theta, second part is considered as phi. Then I got this cos theta, then cos phi. On the basis of cos theta, I found sin theta. Then by using cos phi, I found sin phi. Right? After getting all these 4 values, I apply cos theta plus phi formula, means cos A plus B, compound angle formula. So cos minus sin. Then I substitute the values and then do the calculation. So after doing the calculation, I got this answer. Okay. So next sum. See here again the question is prove that 2 into tan inverse 1 upon 3 plus tan inverse 4 upon 3, that is equal to pi upon 2. So left hand side is 2 into tan inverse 1 upon 3 plus tan inverse 4 upon 3. Okay. Now property of inverse trigonometric function. We saw this property that 2 into tan inverse x that is same as tan inverse 2x upon 1 minus x square. Right? We can write this 2 into tan inverse x as tan inverse 2x upon 1 minus x square. Okay. So 2 into tan inverse 1 upon 3. Here x is 1 upon 3. So on right hand side also, in place of x I am writing 1 upon 3. So 2 into 1 upon 3 divided by 1 minus 1 upon 3 whole square. So that is equal to tan inverse 2 upon 3 divided by cross multiplication. So 8 upon 9. Okay. So left hand side is tan inverse 3 upon 4 plus tan inverse 4 upon 5. Right. And this I got tan inverse 3 upon 4. Now since this is what? See 2 into tan inverse 1 upon 3. 2 into tan inverse 1 upon 3 is reduced into tan inverse 3 upon 4. Okay. So left hand side is now what? Tan inverse 3 upon 4 plus second term as it is. Second term is tan inverse 4 upon 3. And this is what? This is in the form of tan inverse x plus tan inverse y. Okay. So before using the formula, what I have to check? I have to check the xy value, whether it is less than 1 or xy is greater than 1. So xy is what? X is 3 upon 4 into 4 upon 3, right? So cancel, that is equal to 1. So x is also greater than 0, y is also greater than 0, and xy is equal to 1. So we are going to use the first formula. So first formula, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where x is 3 upon 4 and y is 4 upon 3. So that will be a 3 upon 4 plus 4 upon 3 upon, now denominator is 1 minus 1. So denominator is 0. Denominator is 0, that's why value will be infinity. Okay. Now tan inverse infinity. Tan inverse infinity is pi upon 2. Tan inverse infinity means, see, the term is tan inverse infinity. That means, and we know that. Okay. Let me clear all the screen. Okay. Now see, we know that tan 90 degree is infinity. Tan 90 degree is not defined. Now this 90 degree can be written as pi upon 2. So tan pi upon 2 is infinity, right? Hence tan inverse infinity is equal to pi upon 2, right? From definition of inverse trigonometric function. So tan inverse infinity is pi upon 2, and that is equal to right hand side. So hence 2 into tan inverse 1 upon 3 plus tan inverse 4 upon 3 is equal to pi upon 2. Okay. Clear? First we have to use the property in first term. First term is 2 into tan inverse 1 upon 3. So I use the property and convert this into single tan inverse term, that will be tan inverse 2x upon 1 minus x square. Okay. Then I got this term tan inverse 3 upon 4, and the second term is tan inverse 4 upon 3. Then I apply the formula tan inverse x plus tan inverse y formula. Okay. Now since xy is equal to 1, therefore I got denominator as 0, and denominator is 0 means value is infinity, and tan inverse infinity is pi upon 2. Okay. So with this I am concluding this video. Even this chapter inverse trigonometric function is completed. Okay. So thank you students.